Okay guys, today I'm gonna create a tutorial for my Romanian students on English about Git, GitHub, our workflow in Git with GitHub, and source control management systems, ASP.NET, MVC5, eventually MVC6. So let's start with one example. What is a source control management system? It's a software which tracks all the changes in a folder in your hard drive. So this is, generally speaking, what it is. For example, I'm starting a new project. I'm gonna give you one example how we used to do the things many years ago. So I'm starting a new project, let's say in one of my folders, and every day when I finish project test, for example, and every day when I finish with project test, and every day when I finish, I used to do that. Maybe other guys did the same, I don't know. I would say we did that because I used to work like that with other guys, but in any case our workflow was something like that. Add project to archive. I used to choose, for example, zip and say today is 14th of May 2016, and I used to say something like that, and maybe underscore 1, which doesn't give me actually the idea what it is, so I usually mentioned started the project or something like that. A descriptive name which tells me what is inside of this folder, what did I do. So by the end, diagnostic message, close. You got the idea. I'm gonna remove this folder, I don't need it anyway. Okay, so here we go. We have one folder somewhere in our system, and every day when I finish working, I'm creating one archive with zip or WinRAR or whatever, and I'm adding this zip to another folder. And the revision, usually it's called, as I said, project name, date 05/05/2016, and something which describes what is inside, what did we do. And eventually we will get something like a database into this folder where we keep all these zip files. On the next day when I finish working, I will do the same. Project 06 on the next day, 05/2016, and I will say, for example, I created something else, and so on and so forth. Eventually this folder fills with all these revisions. Why I'm doing that? Simply because when I'm working on the project, one day I may make general mistakes and the project may stop compiling, or I will get errors, or I did something stupid. So I want to have a point back in time to which I can go back. So let's say today I have done, okay, let me give you this example. I insist project test 1, for example. Let's say I'm starting a new project and I'm working here. I'm creating, it doesn't necessarily to be a software project. You could start, for example, writing a book or something. Test, so project test 1, and here we go. Let's say today I'm happy with whatever I have done. In text test I could put only one line of code or whatever it is, and after that I will create one archive. I click with the right mouse button, add to archive, say zip, and I will say started the project. We run diagnostic message, see project test, zip write error in the project test stand the project zip access denied. Okay, so I see what the problem is. Of course, I should create this in a folder where I have rights to write. Okay, so open in Windows, whatever. I can move it here in the desktop just to simplify things. Okay, you got the idea. Now it's gonna allow me here on this folder on the desktop to create the zip file. So I can say 05/05/2016 started the project. Here we go. I could have another folder which I could call repository and I can collect all my revisions, because what I have here, my archives in this folder, they will be in chronological order, and I'm doing this manually. On the next day when I finish typing something else, let's say I have typed second line here, test2, save it. I have created another file which I can call test1 or something else. When I finish working, I can add this to another archive, and I just have to be consistent. I can say 06/05/2016 added new file or whatever makes sense to you, and after that you add it here. So those are different revisions of my project. They give me a chance to go back if I do something terribly wrong with my project. It gives me also another advantage. I can share my project with somebody else. Okay, all this we used to do manually, at least I used to do manually. So there is a software built in order to do that. There are source control management systems which allows us to track the changes in a given folder, and also they allow us to collaborate and many other things as well. To experiment, for example, you can create branches. Okay, so one of those source control management systems is called Git. All you have to do is just go ahead and find source control management system, Git, download and install in your system. Git SCM, Git source control management system. Download for Windows. The system recognizes that I'm running Windows here, and install it. So Git is a source control management system. There are a lot of source control management systems. Let's read what it is. Git is a free and open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. That's absolutely true, and I explain it to you how we used to do it and what Git actually is doing automatically. And another source control management systems, there is Mercurial. I used to use Subversion as well, CVS, and basically that's it. Maybe I came across another which I cannot remember right now. So that's it. Now we're going to talk about the Git. So initially I used to use the centralized source control management system, version control system, which is called Subversion. It is centralized. So there are two types of source control management systems. One of them is centralized and another one is distributed. This one, Git, is distributed. Why? Because there is no central server which we can point and say, okay, this is my repository, this is the server where my code base lies, and you have to download everything from this central server and after that you can push everything what you have done to this server. Okay, let me show you this scenario. Okay, we have a server somewhere in internet. It plays the role of the central source control management system. You're running the server software. Make difference. This is a server software specially created to be run on a server somewhere in internet and allow us to communicate with it. On another computer you install the client side. For example, we used to use Tortoise SVN. Of course there is a command line tool as well, as far as I remember. And what we did is we work all day long, and after that, or when we decide, we push all the changes, we commit all the changes to this central server. On the next day all guys do that. So let's imagine that we have our collaborators here. This is the second guy. This is the very same source control management server which our collaborator is communicating with. So all we have accounts here on the server, and we commit our changes to the central repository, and after that we pull or we update our local copies of the code base. Okay, what happens if the server dies? Nobody can work. We're losing everything. Actually, if you have here repository, you can recover somehow, but without this central server you cannot work. The distributed source control management system as Git offers something else. All the nodes are equal. So here, let's say I'm starting a new project and I'm adding it to a source control management system. I can play, for example, the role of a central server if my computer is 24/7 connected to internet and available. So everybody else can clone the repository on its computer, can start working, and after that push the changes back to this computer. But each one of the nodes can play this role. Okay, I started with the source control management system, and here it is, another computer. Actually the picture looks exactly the same like the centralized control management system, version control system or source control management system. But actually there is a difference. There is no central server. If this computer dies, each one of the collaborators has the entire database with all these revisions which I mentioned to you. Imagine the repository this way, like zip. Of course, the source control management system does the things much smarter, because here, even though we change only one line of code, again, the size of the zip file of the archive is very big. We compress all the files, even though we change only one line. The source control management system does the things much smarter and more intelligent. Remembers only the differences and many other smart things. Okay, so there is a company called GitHub which offers a computer where we can push our repository. We keep our repository on this server. This server is available 24/7, and we don't have to care about any of us connected 24/7 to internet. If something happens with our computers, for example, we still have our source control management system, our repository, on the safe place somewhere in the data center of GitHub. This is a company which offers this service. This is a social network for all developers. And what we are gonna do is we are gonna use Git. This tutorial is for very basic is very basic for the guys which don't know anything about source control management system. So if you know something about source control management system, maybe you will learn something from the workflow. I have created one workflow for my students, which is actually not something very new. Maybe other guys also using it. In fact, they're using it as far as I know, but I'm gonna show you that right now. Okay, so let's create one repository on GitHub first. Of course, we can start vice versa. We can start creating a project on our local machine and after that push it to GitHub. We can create repository on GitHub and after that push all our code which we have created on GitHub. I'll start by creating a repository on GitHub. So notice this, I'm gonna play 3 different roles. One of my roles is gonna be played by a guy by the nickname Wingman007. This guy is gonna play the role of the mentor. I will have a second player which is called Cool CSN. This guy is gonna be a team leader. Okay, let me type the roles. So Wingman007 is mentor. Cool CSN, and I'll explain you their roles. Cool CSN is our team leader, and Cherysharov is our team member, just ordinary team member. So those are my 3 roles. Right now, I should type this with different colors, but I didn't do it. So maybe this is gonna make the things even more clear. I'm not sure if that helps, but in any case I did it with red. So right now I'm gonna log into GitHub with my first account as Wingman00007 and I'm gonna create a repository. Let's say I have a great idea for creating a software for keeping information about my movies at home. So this is what I'm gonna do. Wingman007. I'm gonna type the password. After that I'm gonna show you what I have in mind. Okay. Now I'm gonna create one repository. Here I have a lot of repositories, and as you can see I have already created this repository for another student, so I'm gonna remove this and start over. We're gonna take advantage of the fact that there is such a repository, so I'm gonna show you how to remove repository. Educational project is what I'm gonna say, and I don't wanna type it. So here we go. If you want to remove repository, you click on the settings, and after that go in the danger zone, click delete repository, choose OP movies, and delete this one. So I'm gonna start from scratch. I'm just gonna create it right now. So let's say I pretend to be a visionary guy and I came up with the idea that I want to create a software for keeping track of my movies at home. I will start by creating a new repository. Of course the scenario shouldn't be could be different, not like that. I will say OOP, Object-Oriented Programming 2016 movies. Okay, this is an educational project. I don't want to type that, so I'm gonna paste it, and I'm gonna say initialize this repository with readme file. You can add gitignore, or you can add different licenses. I'm not gonna add license, but I strongly encourage you to go ahead, read the licenses, and add license if you like. I'm gonna add only readme md markdown file. Creating repository, create repository, and voila, the repository has been created. There is only one file called readme md. What is this Markdown? Markdown is a minimal language which allows me to format what I'm typing. It looks like HTML. Actually, it doesn't look like HTML, but does the same job for formatting the text. Here we go, but looks differently. For example, if I want to create header, I would type h1 in HTML, but here instead you just type pound, and that's enough. So it tries to make our lives easier, but I keep asking myself, what is easier, to learn once something which is very difficult, or learn 1000 times less difficult things? And this is what we're facing in our world, in IT, information technologies, but that's a philosophical question. I'm not gonna discuss this right now, so let's continue. Now, so Wingman, our visionary guy or our mentor, just created a repository. He doesn't even have this repository on his local machine, and he can edit, for example, this readme MD file and add more text, explain what the idea is, or usually the guys type code. I can edit this file here directly in GitHub. GitHub allows me to do that. By default, the source control management system doesn't care about editing the files, just keeping track of them. But GitHub actually allows me to edit this MD file, this readme MD file. So I can type more information. It's going to be easier for me without even downloading the entire project. Of course, when you start coding, when you start creating a project, you have to download the project because you're typing source code, unless you're so confident that what you're typing is absolutely correct that you don't have to compile and run. But I don't know, that's probably impossible. In any case, you can change some of the files, you can edit some of the files directly in GitHub. I strongly discourage you to do that. Actually, do it by downloading. Not strongly discourage you, but yeah, it's much more convenient just to download the file and do everything on your machine. It depends, of course, it depends. Maybe it's more convenient for some simple files just to edit online directly in the browser. Whatever. So now, after adding the code, we have a new project. Let's say I'm just playing a role right now, and this is exactly how we are gonna work with the students. So as a mentor of my students, I'm gonna create one repository for each one of the projects they're gonna work on. After that, they will gather together, not more than 10 guys. I think 7 also, it's very good number of students which can work together. They can create teams, and the team leader can clone the repository and start working with the team, add collaborators, and start working as a team on the project. Okay, let me give you another scenario. Let's say this visionary guy who just invented this brilliant idea about creating a project for the movies at home, keeping track of the movies at home, inspires somebody. And this somebody is a team leader. His name is CoolCSN. Just to simplify things, it's a artificial story, CoolCSN. And I'm gonna log in as CoolCSN right now. Wow, very long. Okay. This guy has different repositories. By the way, he already cloned movies, so I'm gonna remove this from his repository as well, because we don't need it, because we are gonna pretend that this is a new idea, and we just will pick up this idea and start developing, start helping this idea to become true. Okay, so now notice that those are the repositories of CoolCSN, our team leader, one of the students. Why our team leader, CoolCSN, should clone or fork the repository, as they call it in GitHub. First, let's say he discovers Wingman 007 in GitHub. He starts to browse all his repositories and he, by chance, stumbles upon OP 2016 movies. Okay, he clicks on this project and he reads the README file. He likes the idea, he likes the code that has been created, and CoolCSN now can contact the owner of this repository by email, for example, can send him one email and ask him to add him as a collaborator. But say Wingman, our mentor, doesn't know the guy, doesn't trust him, and he says, okay, just type a little bit, contribute to the code differently, fork the repository, work a little bit, send me pull request, I will check your code, and if I'm happy, I'm gonna merge whatever you have created to this mainstream project, to this original project. Okay, so our CoolCSN guy doesn't have push permissions. He cannot write into this repository. He just can clone, he just can download the project, but he cannot collaborate directly. So now what we can do, in order to collaborate, if he doesn't have been added as a collaborator, all he can do is just fork the repository. Notice this, right now I'm in the Wingman 007 account and the project is called OP 2016 movies. So now our CoolCSN is inspired by this idea and he wants to fork it. So he will have this project in his repositories as well, and as soon as this account is his account, he will be able to do with this clone or fork whatever he likes with this code base. He can change it, he can do whatever. Okay, I'm gonna click fork. You probably will not be asked these questions. I'm choosing CoolCSN. Okay, so now forking the project from Wingman 007 into the account of CoolCSN. Notice this now. This fork shows us that this project has been forked, is not the original project. Also, CoolCSN. Now this repository is located in the CoolCSN account and it's called 2016 movies. Now I'm gonna show you how to use Git, but Git which comes with the Visual Studio. I have Visual Studio 2016. Now let's start working on the project. First we have to download this project on our local machine, and after that start tweaking the code, or we're gonna create a project ASP.NET MVC, and if I can, we're gonna create ASP6 project. Okay, so now finally my Visual Studio is up and running. So let's see what we are gonna do now. I'm not gonna create a new project because the project has been already created, or I'm gonna create a project but I'm gonna create it inside of the repository. I'm gonna run the Team Explorer. View, come on, Team Explorer. We're waiting for the Team Explorer to show up. Okay, now since Visual Studio 2013, you can notice that there is a Git included in the Visual Studio. So this is what I'm gonna use. I used to download Git, the source control system, from here, version control system, and after that use it from the command line. But when I updated my Visual Studio 2015 Community Edition, it asked me to remove my Git and install something else. Okay, that doesn't matter actually. Okay, now what I'm gonna use is I'm gonna use the internal Git which comes with Visual Studio. I have my repository in internet at this address. There are two protocols which allows us to communicate: HTTPS and security shell SSH. HTTPS is the protocol which Visual Studio supports. So I'm gonna say clone repository because this is one existing repository, and I'm gonna put the URL. Let's notice where the project is gonna be created. User Stoyan source repos 2016. Okay, let's go to C and let's find this folder just to see what is going on. Users Stoyan repos. Come on. Source repos, and we should see that this folder is empty. This is the default location. I'm gonna say clone. So whatever is on GitHub, please clone it here. Here we go. Now let's take a look. Now I have the project downloaded to my local hard drive. By the way, here it is where the database of Git is located, in a folder called .git. If you ask yourself where these different revisions are, well, where this information is, no magic. Okay, this is how the things are looking right now. Okay, so here we go. This is our repository. Let's click on the repository. I double click, and this is what we see right now. If I say open, nothing is gonna open because the repository is empty. There is no, at least there is no solution which I can open, which Visual Studio understands. There is nothing. Inspired by the idea to create such software, our team leader CoolCSN, which I'm playing right now, I'm playing this role, decides to create a new project. He clicks on the new, and he would say, okay, this is gonna be ASP.NET 5 MVC 6 application. Let's see how that works. And it's gonna be called Movies ASP.NET Web Application. Let's call it Movies because it's gonna be very simple. Also, you can check or uncheck create directory for solution and create new Git repository. Add to the existing repository. This is what I'm expecting. Okay, new. Nothing's gonna change. Movies. This also should be checked. Okay, so I'm gonna say okay. Let's try with ASP.NET 5 template web application and see what happens now. Movies test. I'm gonna click OK. Here we go. Here we go. Microsoft Visual Studio following attempting to run DNX designer.NET execution design. Time process, no connection could be made, blah blah. Okay, let's ignore this right now. We'll see what it is later. Okay, so now we have our newly created ASP.NET 5 MVC 6 application. The file structure for ASP.NET 4 point something is different, MVC 5 is different. MVC 6 looks totally different now. Models, controllers, and all this kind of stuff. Migrations, models, services, views. Okay. Now, we just created a project which resides into this folder. Movies. Let's see what it is. Visual Studio, source, movie. Here we go. Visual Studio has a strange way to call the things. The checkbox used to say, as far as I remember, add to the source control management system. Right now was telling me create new source control. We have already source control management system created, Git, but let's ignore that for now. Okay, so we're not gonna discuss that. Let's see in our Team Explorer the changes. Remember, if I told you actually, not if I told you that the source control management system keeps track of all files into this folder. OP 2016 movies. We just created a new folder which is called movies. Visual Studio created Git attributes and Git ignore file. In Git ignore are all the files and folders which shouldn't be tracked by the source control management system. Probably is empty, but let's check that. Oh, a lot of things. Visual Studio added all the things which shouldn't be included. Git ignore and Git attributes. I'm not gonna open this file. Our project is in movies because we checked the box, create the solution, create a new folder for the solution. If I uncheck this box, all these files will be created here in this folder. In any case, we see all the changes. In our case, those are all new files which have been created. Okay, let's go back to Solution Explorer and let's run our application to see how it looks. F5, and let's see how our application looks. And voila, finally the application is running. It uses Bootstrap CSS framework. The design is responsive, as you can see. There is a carousel and it looks very, very nice. Okay, so without writing even one line of code, we have created application. Diagnostic tools we have here, I don't need them right now for this tutorial. Okay, so our application is running. Let's look at again Solution Explorer. Now, I have to talk a little bit about design patterns. What are the design patterns? The design patterns, this term has been invented by Christopher Alexander, which is not even a software engineer. He is an architect. He looked around and he said, when we do architect different houses, we usually often use common solutions for common problems. I can give you one example. We want to possess land, for example. How can we protect it against other guys not allowing them to enter our property? We can dig a ditch, for example, or we can come up with some kind of a canopy solution, or fly air balloon and just observe the territory which we possess and not allow anybody to enter with a shotgun or something like that. A lot of stupid solutions. Christopher Alexander says, okay, most common practice is just to build a fence, and that's enough to protect your property. we adopted the design patterns from architecture, and Eric Gama and another three guys created the book Ganko 4 Design Patterns Element of Reusable Software. This was the first book in the software the first book which I met. Actually, I don't pretend this is the first book for design patterns in the software, but I think it is the first. I cannot claim this 100%. I cannot say this is 100% true, but I'm almost sure that this is the first book for software engineering, for the design patterns in the software engineering. Martin Fowler right now is very popular with his book Patterns for Enterprise Application Architecture. In this book he mentions the MVC design pattern. In the first book also it's mentioned the MVC. So our application should have logical layers, and in MVC design pattern we create these layers in a way such all the presentations goes to the views. Whatever the user sees, all the classes or whatever, it's responsible for the presentation layer is put in a layer view. It's a logical layer. It doesn't have to be separated in different folders, but we usually do separate them in different folders. Model. If you watched my previous tutorials, probably you saw how I created a model of a person in my virtual reality. So all these models go here in the models folder. And the controllers. The controllers are the puppet masters. The controllers receive data from the view. The view sends the data to the controller. Okay, so I'm gonna give you a different perspective. This is the controller. This is the view. Oops, sorry. This is the view, and this is the model. So the model here has all the models of our domain. View. Actually, you can think about the model that's extra simplified. You can think for the model like for the database. So model is representing the database, but this is very simplistic, as I said. The view. View in one web application actually is built using CSS, HTML and JavaScript. View is responsible of what we are showing to the user and how we are showing it. So the controller gets data from the view. Let's say our customer presses a button and sends a form to the server. The controller receives this data, decides how to respond, what to do, to communicate with the model, extract data or send data to the model, and after that decides what other view to show and returns HTML, CSS and JavaScript eventually. Okay, the view also can receive data bypassing the controller, but only in this direction. Okay, this is the MVC. Let's take a look now at our controllers, our views and our models, these folders, and try to figure out how this application works and how can we hack it. So let's open the home controller and see what is inside. You'll see that all these things, all the things we have inside actually are very well known. Okay, so the controller is nothing else, the puppet master is nothing else but a class. You'll see for each one of the so-called pages, because this is how we accept actually what we see here, there is a method which is called action. This is the first action responsible for representing this page, for creating this page. about. Method about takes care of about page. Let's click on about page to see what is inside. View data. Okay, about your application. And there is a contact. Contact page has been built by using the contact method. Let's see now the correlation between the controllers, the methods called actions in the MVC paradigm, and the view. So each controller in the view has a folder. For each controller we can expect to have a view here. For each action we do have view script. About action, about view script. Just to see that we are in charge, let's change the index view script for the index action. Index action also is called landing page, because this is the default page which opens when you don't mention which action you want to be executed. Okay, let's change here something just to see that we are in charge. Okay, let's look at the content of the view script. Based on the project, we identified extensions you may helpful. Yeah, I don't want more extensions right now. Learn more. Let's look at the page, how it looks. Here it is, our home page. Notice here the URL. You'll see that we reach different controllers and their actions by typing the name of the controller and after that the name of the action. So logically, if we want to go to home about, we should type home about. If you don't type anything, it's going to be called index action of the given controller. Here it is. Okay, about. We'll get to the about page now. Index. We're getting back to the home page. Okay, I want to change something. Learn how to build ISP applications that can run anywhere. Let's change this text and let's say this is great. This is great. Save it. Let's refresh our page and see if we made a change. So let's prove that actually we are in charge. We understand what we are doing. Apps that can run anywhere. This is great. Voila. As you can see, now we know what to change, which file to change, in order to change the text on different pages. Once we answer some of the questions, let's say our cool CSN guy, our team leader, has done his job for today. Let's stop the application and let's push it to our repository. Here in our repository we still have only one file, even though we added a lot of files to our project. In order to do this, we go to the Team Explorer and we will say show me the changes. And here we will see all the changes which have been made. Okay, so now enter a comment and I'm gonna say now this is like creating the zip file and adding it to the repository with all the archives. So let's say the project the ISP.NET project was created. This is what we're gonna say. I'm gonna say commit all. We are waiting now all the changes to be committed. Okay. Now, in order to push all this information to the repository in GitHub, we have to sync now. As I said, Visual Studio is using Git, but it uses a little bit strange terminology. Okay, I'm gonna say sync, synchronize. Branch master, outgoing commits, project was created, outgoing commits 1, I can say push or I can say sync. Now it's gonna ask me again for username and password. If you're at home, you can enter username and password. This is cool CSN, so I'm gonna type his username, I'm gonna type his password. Okay, we are waiting for the code to be pushed to the GitHub repository, to be synced as they call it here in Visual Studio. Successfully synchronized incoming and outgoing commits. Let's see what has been changed in the cool CSN OP 2016 movies. When we refresh, we'll see now our project has been pushed to the repository and everybody can work together with us. Okay, now our guy cool CSN is very happy with what he has done, and now he wants to add collaborators. Click on the collaborators and say I have Cheresharov as a collaborator. I will add this to the collaborators. So this is our workflow. Now Wingman has created one repository. He doesn't allow anybody actually to push to change the repository without his knowledge. So the only way actually we can work on this project is just to fork it. And this is exactly what cool CSN has done. This is our wingman. This is our guy. He is the visionary guy. He has created the project. He threw initially the idea. Cool CSN is another guy. Wow. Sorry, my drawing is not perfect, but hopefully you understand. Okay, cool CSN has forked the repository. I'll put here fork. Okay. He has everything in this project. He wants now to allow other guys to work together with him on this fork, and he can invite, for example, our guy Cheresharov. So both cool CSN and Cheresharov can push to this repository. They work together. Once they finish, they can send a pull request back to Wingman 007 and say, hey, look at our code. We have added a lot of things to the code base. Look at the code, and if you like it, please merge it to the original repository so other people who are following your project actually can benefit from that. You understand that this is a very flexible model which allows us, for example, here we can have another team which can fork this initial project and work on it as well. As far as I know, Linux core works this way. Linus Torvald doesn't allow a lot of collaborators to the repository, but everybody can clone the repository, can organize a team, or can work alone, of course, and after that send a pull request. Of course, it doesn't end. This pyramid doesn't end on the first level. Somebody else who likes the clone, this first clone, can fork this clone again. Here, these guys also can have a team, work on this clone, and after that send a pull request to the cool CSN or to these guys, and after that they can merge it here, and after that send it back to the Wingman 007. So it's really endless. Okay, now let's see how the things are looking for from the viewpoint of Stoyan, of Cherysharov, which is an Ordner team member. Now I'm gonna play the third role. I just show it to you how I play the second role. So I sign out, and I'm gonna pretend right now that I don't know anything about this project. I just have been invited to work on a project, and I will discover this by going to my GitHub repository. Okay, so now I'm gonna log in as Cherysharov. Yeah. Okay, so let's pretend we are Cherysharov. We just logged to our repository, and we saw that somebody actually invited us to become collaborators, and I see this repository in my repositories. Notice that the symbol is a fork, which shows that the repository actually it's a fork, but right now I'm Cherysharov. It shows me that CoolCSN is the owner of this repository. It doesn't matter to me. If I'm interested, I can collaborate. Of course, probably this has been negotiated before, so I shouldn't be surprised that I have all these files in my repository and I can work together with this guy CoolCSN. Okay, I'm gonna do something else also. I'm gonna remove this entire folder from this computer because right now I'm pretending that I don't know anything about the project. Also, we will continue discussing the ASP.NET MVC. Okay, so the folder has been removed. Cherysharov doesn't know anything about this project. He just learned about the fact that he has been invited to collaborate on this project by CoolCSN. Okay, let's say he likes the idea and he wants to collaborate. Let's start his Visual Studio. Okay, Cherysharov now is gonna clone the repository, but he's gonna add the URL, and the repository will be created in user, Stoyan, source, repos. Sorry, I'm on the very same computer when I'm playing these three roles, so maybe you don't see very well the difference between Wingman 007, which is our mentor who has created the project, CoolCSN, which is the team leader who just forked the repository and worked a little bit on it, and after that pushed what he has done to the repository. And now I'm playing the third role, the role of the Cherysharov, who is a team member. Now Cherysharov on his computer is gonna clone this repository. Click clone and the repository will be downloaded, will be cloned here. Okay, without doing anything, as you can see, Cherysharov has the project. Okay, now he doesn't have to create a new repository. I'm gonna double click on this repo. He doesn't have to create a project, and I'm gonna say open, or click directly on movies. Open. Now make the difference. Before CoolCSN clicked on the new in order to create a repository. Now I clicked a cherish of team member, just click on the open to open the existing repository, existing project, and in a few seconds we'll have whatever CoolCSN has created, the team leader has created. As you can see here, npm packages has been installed, npm get, you see. So Node.js actually it's running somewhere behind the scene. Also, if you look at ISP.NET 5 MVC 6, you'll notice that there is a gulp building system and also bower. We'll see that gulp or grunt. We'll see that just in a minute when npm finishes his job. Node package manager. Okay, so finally everything has been installed. You see here bower, npm. If you look at the code, you'll see what has been installed by npm node package manager. In any case, so Solution Explorer. Let's go to the Solution Explorer. Gulp file. This is the configuration file for Gulp node building system, JavaScript building system, and there is a bower somewhere. Project readme startup gulp. I don't see bower. Anyway, so let's open the controllers. Home controller. As a CoolCSN, I showed to you how to change something. We just started to change something. Now let's do something else. Let's try right now to create our own controller. Click with the right mouse button, click Add and say Controller. MVC controller with view using entity framework. Entity framework, okay, let's see that. Add. I just wanted one empty controller. Model class, no, I don't have any models right now. Controller name, so obviously I have to create the controller myself, which is absolutely possible. I don't know why here I don't have this template. Common controller. MVC controller with views entity framework. Actually, this is even better. Okay, so check here to go online and find more scaffolding extensions. I don't need scaffolding extensions. Actually, as a base, I can use the home controller, and I'm gonna create another controller. I also can type. Controller is nothing else but just a class. Into a folder controller with a specific name. And I'm gonna call it right now Hello World Controller. Of course I have to choose the server side and say class, and I'm gonna call this Hello World Controller. Hello World Controller. Add. I still don't see it. Hello World Controller. The controller is nothing else but a class which inherits. I'm gonna remove here actions, these actions, This is called hello world, of course. This is index section, and I'm ready. Let's try by returning a string. Action result. And I'm gonna put here string. Return hello world. Let's see what happens now. Let's build the project. We actually haven't run this project on the computer of Cherysharov, so we're gonna do this as well, just in a second, once the build is done. Okay, let's click on AX Express. And voila, application is running. Now, we already know how to get to different controllers and their actions. Let's see the configuration of the application. Application settings. Login, information, data, and all this kind of stuff. Okay, we have been able to figure out how to get to the project, to the different controllers. So let's try to do that. Okay, I'm gonna put here hello world. I just created a hello world controller. Now I wanna get home hello world. I have to create this folder. Voila, hello world. It's not using right now two steps view, and that's why we see only what we have put here in the controller. We don't have a view at all. Okay, how we are gonna create new page? Of course, this we cannot call a page in one web application, but let's call it page. Welcome. Public. Let's return again string. Welcome. Return. Oops. Return. Welcome. Let's build and try to access this action. Build the solution. Yeah, I want to stop debugging. Okay, now once we are done with that, let's refresh here. Hello world, welcome. Let's see if we can access welcome action. Welcome, this set can be reached. Probably still working on the background. Let's see again. Welcome. Okay, I have to start again. Internet Explorer. IS. Obviously. Okay. Wow. Let's try now. Welcome. Should say welcome. Okay, now how we are gonna get parameters from the input? Let's say I wanna send the standard HTTP way name and num times equals 4. Okay. Right now the application doesn't handle this input. So how are you gonna do that? Let's try it this way. String name integer num times, and let's give a default value of 0. Okay, let's build again and see what happens. Okay, this time I don't wanna start debugging. I don't gonna hit this button. I'm gonna press Ctrl F5 to run the application without debugging. Okay. Hello world. I'm gonna say welcome. Voila. Now I wanna send name equals Stoyan and num times equals 4. Okay, I still don't handle the input. Now let's say I wanna do something like that. String format, whatever I get, string format welcome. I'm gonna put here welcome name, which the user sends me, and at the end I'm gonna finish with num times equals like that. Name num times. Okay, let's build. Num times capital letter. There is an error, so let's build it again. And see what happens now. Curious to see if we can get the input parameters. I bet we can. Okay, so refresh. And voila, look at this now. We're able to send parameters to our application. If here we put Ivan, voila, we get Ivan. So now we know how to send parameters to our methods, which are called actions. Actually, returning something as a string from the controller is not a very good idea. So that's why I'm gonna change right now. I'm gonna change the return value, and I'm gonna leave it as it was before. Okay. Return view. I'm gonna create views right now. Okay, return view.